97.
97. P.5, 97. A second, let me get my book and grab that. Let's see here, P6, P. P7, 95. I'll make sure I've got that one right. That's the one that's 3x squared equals 60. Is that the right one?
I think it's x plus 3 to the 1/2 power plus x plus 3 to the 3 second.
Okay. That doesn't, let's see, P5, 90. Now, let me see here. P5, 90. That looked like x plus 3 to the 1/2.
Yes.
Okay, let's see. X plus 3 to the 1/2 minus x plus 3 to the 3/2. Okay, this is one of those where we have a common base, which is x plus 3, and we want to rewrite the exponent. So let's go ahead and rewrite that exponent. So that could look like x plus 3 to the 1/2 minus x plus 3 to the 3/2. We could rewrite that as 2/2 and 1/2. If we multiplied those together, we'd get 3/2, wouldn't we? So we could say that's x plus 3 to the 1/2 and x plus 3 to the 2/2. Would you agree with that? What we're going to do is just rewrite this. 3/2 is the same as 1/2 and 2/2. Okay, that makes sense?
Yeah.
Okay, and then 2/2 is really just 1, isn't it? So that's x plus 3 to the 1/2 minus x plus 3 to the 1/2 times x plus 3. And it looks like these terms are the same, aren't they? So it looks like we ought to be able to factor out and x plus 3 to the 1/2, and that leaves 1 minus, and then this x plus 3 here. So that looks like it's going to be x plus 3 to the 1/2. So now we have to simplify this. X plus 3 to 1/2. And this is going to be 1 minus x minus 3. So that's 1 minus 3. That's going to be x minus 2, isn't it? So we're going to look like x plus 3 to to the 1/2 times negative x minus 2. And generally, we want to express these as a positive x here. So if I factor out this negative, I put that out in front, x plus 3 to the 1/2 times positive x, positive 2. So it looks like we're going to be negative x plus 3 to the 1/2 times x plus 2. Looks like it would look like that. Okay. The real concept here is we want to take this 3/2 and break it up into something different, say 2/2 and 1/2. When we multiply those, we get 3/2, and then we can simplify. Any questions on what we did there?
No, thank you.
Okay. Okay, in case you logged on late, this is just an optional session for anybody that has questions on anything we've covered anywhere during the course. I want everybody to remember that the final is on the 15th, next Wednesday during class hours, but please be logged on 10 to 15 minutes before class. So I've got a list of everybody that's logged on, and I've got a test ready for each person that's logged on that I can send out. So you'll have a full hour and 50 minutes. Okay, that'll give you time to download the test and work it and send your solutions back to me. Okay, other questions that you might have that came up during the course?
Can we go over 109 in the same P.5?
P.5 109. Let's take a look what that says. P.5 109. See if we can see what that looks like. P5 109. Is that the one that starts out x to the 4
Yes.
minus 5x squared y squared plus 4y to the 4? And what are they asking us to do here? Let me see what they're asking for here. See how they phrase it. P5. Just factor completely. Okay, so we want to factor this thing. And what's causing us the issue, I suppose, is the fact that we've got a x to the 4 here. I guess a couple ways we could think about it, but we could say what times what. This has a leading coefficient of 1, so we could say x squared and x squared there. And then we've got 4, which factors into 1 and 4 or 2 and 2. So we've got 1 and 1 on the first one, and either 1 and 4 or 2 and 2 on the y to the 4th. And we have to do, when we do our FOIL and we do outer plus inner, we have to come up with a 5. So outer, if we used the 4 and 1, outer is 1, inner is 4, 4 and 1 is 5, that would work. If we take this 2 and 2, outer is 2, inner is 2, 4 and 2 and 2 is just 4, so that wouldn't work. So we're going to use 1 and 1, which is this x squared, and then we'll use a 4 and a 1. So we'll say 4y squared, y squared. That'll give us 4y to the 4th. That'll work. And then this is a positive, saying the signs are the same and they're going to be negative. So it looks like we're going to put a negative there and a negative there. So we end up with x squared minus 4y squared, and then x squared minus y squared. And a lot of us are going to want to stop right there. Say, hey, we did our factoring, but we have to factor completely. So we take a look at this and say that looks like a squared minus b squared, doesn't it? Which looks like a plus b and a minus b. So this, I guess we could say the same thing for here. That looks like a squared minus b squared, where a equals x and b equals 2y. Here a equals x and b equals y. So we're going to factor both of these. Okay, so x squared minus 4y, so that'll give us an x and an x, and looks like a 2y plus 2y and a minus 2y. It looks like a squared minus b squared. So a plus 2y, x plus 2y, x minus 2y, that's for that one. And this just looks like a squared minus b squared, so that's x plus y and x minus y. So now we factored completely. We had to do 2 steps. We had to, in step 1, we factored the first equation and got this. And then in step 2, we factored both binomials of the second equation, leading to this and to this. So we end up with an answer of the binomial x plus 2y times the binomial x minus 2y times the binomial x plus y times the binomial x minus y. Make sense?
Yes, thank you so much.
Yeah. Other questions? We're just doing your questions today. I don't have any lecture for you today. It's just whatever questions you might have. Who else has a question? Anybody?
I have another question. If X,
Sure, go right ahead.
okay. It's for P.8, number 45.
P as in Paul,
Yes,
8,
yes.
number
45.
4, 5. P845. Let's see if I can find one that has that. P. P6. P7. P8. 45. Let's see. Let me read how that question is phrased. P845. A group of people share equally in a $200,000 lottery. So they're sharing 200,000. And a group of people, before the money is divided, 2 more winning ticket holders are declared. So before we have ticket holders, we don't know how many there are. So we'll say the original amount, if X is the original number of people, then 200,000 over whatever that number is would give the original amount of money per person. So I'll just mark that down. Original dollars per person for X people. Okay, and then it says, Before the money's divided, 2 more winning ticket holders are declared. Okay, 2 more. And as a result, each person's share is reduced by 500,000. So we're going to reduce by 500,000. And this is not 200,000, is it? Well, that number's wrong. That's 20 million. That shouldn't be 200,000. That should be 20 million. And then 500,000. So we're going to reduce. So we're going to reduce by 500,000. And the new amount that the people would get then would be the 20 million divided by, and that's, you got 2 new people. So we're going to have X plus 2 here. This is an unknown number of X here, get 20 million. 2 more people get invited, and reduction then is going to be 500,000. Let's see, they said, yeah, as a result, each person's share is reduced by 500,000. So here's each person's share, 20 million over the number. We're going to reduce that by 500,000. And that's going to give us, okay. And so the amount we have in the new group then is 20 million divided by X plus 2. So this is going to be the equation that we're going to try and resolve. And in order to do that, we need to have a common base, don't we? So we have an X here and an X plus 2. So we need an X plus 2 here and an X plus 2 here. And over here, we need an X plus 2. And in the numerator, we're going to multiply by X and X plus 2. And over here, we're going to multiply by just X. Okay, so now we've got the common denominator. We multiply through by the common denominator, and that will get rid of those. So now we should have, what we should be remaining is 20 million times X plus 2 minus 500,000 times X plus 2. And that should equal 20 million times X. Okay, now let's stop and make sure we've got our numbers properly here. 20 million, X plus 2 minus 500,000, X plus 2, 20 million X. Yes. So now this is the equation that we have to solve. So if you were given that as a separate problem, could you solve that equation? If you forget the word problem and just say, here's an equation. It has some values here times X and X plus 2. Could you solve it? Now, while the numbers are large, we still should be able to solve it, right? Now, it looks like we could divide through by at least 1,000. Couldn't we do that? Couldn't we at least take off these zeros here, reduce those sizes a little bit? And then it looks like we could even take off 2 more zeros, those two. So it looks like we have 2, 0, 0, X plus 2 minus 5X, X plus 2 equals 2, 0, 0, X. Do I have my numbers done properly there? And if that's the case, then I should be able to 200x plus 400 minus, and then we have, this will be x squared plus 2x times negative 5. So negative 5x squared minus 10x equals 200x. And if we've done our arithmetic properly. Let's see, we've got a 200x here and a 200x there. So those will cancel. And it looks like we're left with negative 5x squared, negative 10x plus 400 equals 0. And I generally like a positive number here. So I'm going to put a plus and a plus, make this a negative here. So we're solving for positive. And it looks like I could divide through by 5 as well. So if I divide everything by 5, looks like I get x squared plus 2x minus 80 equals 0. If our arithmetic is correct, 5 into that goes that. Okay. So now we're just left with solving for x squared plus 2x minus 80 equals 0. So we'll do that in our normal fashion. 1 and 1. And we want this to result in a 2 after we FOIL it and add outer and inner. So let's see, lots of different factors here. 1 and 80, 2 and 40, 3, 4 and 20, 5 and what, 16, 8 and 10. Any other factors we can put in there? 1, 2, 4, 5, 8, 10. Looks like those would work. So now the question is, we need to do a FOIL and add outer and inner and get a 2. So 80 and 1 isn't going to give us a 2. 40 and 2, 20 and 40, 16 and 5. None of these are going to give us 2s, are we? If we can add or subtract, we're not going to get a 2. 10 and 8 looks like we're going to get a 2, right? 10 minus 8 would be 2. Set that equal to 0. So this will be x and 10 and 2. This says the signs are opposite and the larger is positive. The larger is going to be here. So that's the smaller. So we have x plus 10 is 0, or x equals negative 10. And x minus 2 is 0, or x equals 2. And let's take a look at those solutions. So algebraically, we get two answers, and let's see what it's asking for. How many people were there in the original group? Well, we're not going to have a negative number of people, are we? We're not going to have a negative. So let's see, did I do this correctly here? This says it's 2, but I don't know that if I've done my arithmetic right here. Let's see. I think there's something incorrect in what I've done here, because I don't think this answer is going to check. So let me bring out another piece of paper and see where we've gone wrong on our arithmetic here. We ended up with, let's see. $20 million, that was good. And that x squared, 2x, x squared plus, this is good, x squared plus minus 8, that's good, x squared plus 2x minus 80 equals 0. I think we're good to here. That looks good. So what did we do wrong here? We factor this incorrectly. X and x, we need a 2 here.
I have the answer.
Well, you hang on to that answer. We should be able to generate your answer here. Let's see. This should be x plus, no, is this a 2? That's not a 2, is it? What is that going to be here? I think, let's see here. X squared plus 2x minus, yeah, that's good. That's good. 10.
It should be x minus 8 instead of x minus 2.
X minus, no, I don't think so.
No, because it's in the previous your previous answer, you wrote x minus 2.
Well, let's see here. I think this is correct. That's this x plus, that's this. We got down to here. We had 5x squared, 10x, 400 divided through by 5. We got x squared plus 2x minus 80. I think that's good. You think this is not good?
No, that is correct, but it should
Okay.
be x minus 8 and x plus 10 instead
All right.
of,
So it's my factoring. So let's take a look at the factoring here. So it's
yeah.
x and x, and we want, what do we say? Yeah, we want 10 and 8. Oh yeah, that's
Yes.
right. I wrote 10 and 2. Yeah, we want 10 and 8. 10 and 8. And we want a plus and a minus. So 10, or excuse me, x equals negative 10 and x equals 8. Yes, and we have to reject this answer because we're not going to start with a negative number of people. So yes, so here's our answer. The number of people in the original group is this value here. Okay, we just have to write down the proper values here. Okay, good. So our answer is going to be 8. Does that make sense? Questions on that?
Could you go over like the first part where you were talking about? Is one in the problem?
I'm having trouble hearing you. Can you talk directly into your mic?
Sorry, it says that in the original problem, in the word problem, as a result, each person's share is reduced by 500,000.
Yes.
So is it like, is it each original person's share?
Yes. And here's the original number of people right here. 20 million divided by X is the original number. So 20 million divided by some number X. We don't know what that number X is. Turns out it's going to be 8, but we don't know what it is. But this is each person's share right here. This is each.
Mhm.
And we're going to reduce that by 500 each. So each gets reduced by this. So 20 million divided by X minus 500,000 equals the 20 million divided by the new number. And the new number is 2 larger than the previous number. So that's X plus 2.
Okay. Wait,
And then
sorry.
go right ahead.
Because it says each person share. So isn't it each like 500,000 X? Because it's
No,
each person, or is it on as
no,
as
we're reducing each person by 500,000. So
oh,
each person is this much, 20 million divided by X, and we're going to reduce each share by this amount.
okay.
And that's going to give us the 20 million over the new number over here.
Okay.
Now we could check, we could stick the 8 in here and multiply through, and I'll leave you to do that. But I think you'll find out that checks that the X is not 2, but 8. And that negative 10 value is not a legitimate value.
Thank you so much.
Sure. Okay, who else has a question? I'll just keep this here as a reminder. Make sure we all know about the final date. And I'll wait for other questions.
1.3, 47.
1.3
47.
47. All right, let me find that. 1.3. Where is 1.3 here? Let's see. One, two. One, 3, number 47. Let's see how that reads. 1, 3, 47. 7, that says determine whether each function is even, odd, or neither. Then determine whether the function's graph is symmetric with respect to the axis. And 47 was not an assigned problem, right?
No.
45 was assigned, 47 wasn't assigned. We can do it, but that was not an assigned problem. F of x equals x root 1 minus x squared. And so if we want to see if it's even or odd, we put a negative x in here, don't we? Negative x equals negative x times 1 minus, put in a negative x, it's still going to be the same. We're just going to square it. So that says f at negative x is negative x 1 minus x squared. I guess I could say that is negative times x root 1 minus x squared if we want to bring that out. And let's remember what even and odd functions are. So if this is the value here, if it's an even function, it's here. If it's an odd function, it's here. So we have said f evaluated at negative x. So we've gone through this process. I just put a negative x in here. That's not going to do anything underneath the root. And then I just took this negative out, and we've got this x times root of 1 minus x squared. And that's this, isn't it? Those are the same. So it looks like f at negative x equals the negative of x times root. So here's the positive, here's the negative. So we're going to call this an odd function because it's the negative of this. These two are the same, but it's negative. So we're going to call it odd. Okay.
But how are they the same? Because
They're
what is
both
the
equal
next-
to x. They're both equal to x times the root of 1 minus x squared. X times the root of 1 minus x squared.
But the f of negative x has the negative sign, right?
Yes, right here. It's a negative times this value, and this value and this value are the same. So f at negative x equals the negative of f at x. Here's f at x right here. So f at negative x equals negative f at x. Here's f at x here. Negative f at x. If this equals this, then we're calling it odd. Here's f at x right here.
Oh, okay, got it.
And here's the negative outside.
Okay.
Other questions?
Uh, 1.391.
1391. One, three. See if I can find it here. Let's see, what are they asking for here? That was not an assigned problem either. 1391, 89 was assigned, 91 was not assigned. Before I work a non-assigned problem, are there anybody else have any problems that were actually in the assigned list that you want to go over? One. I'm looking at the right one here. Let's make sure I've got the right problem here. And what do they want us to do here? They want us to find and simplify the difference quotient. Okay, remember what the difference quotient was? That says f at x plus h minus f at x over x plus h minus x, or just the h value, where h is not 0. Okay, so we are given this value here. So let's say f at x plus h, so that's going to be x plus h and minus f at x. So we're just going to substitute the x plus h value in, divided by h. Okay. Now, we want to, in this situation, remember when we have radicals in the numerator, we have to multiply by what? Conjugate, right? And the conjugate in this case is going to be, and I'll take out the f part here. We're just concerned with the x plus h. So the conjugate here is going to be root x plus h plus, and this is root x. Copy it down properly here. So we got root x. So we got root x plus h minus root x. So now we're going to multiply by the conjugate, root x plus h plus root x. And what we do to the numerator, we do to the denominator, don't we? X plus h plus root x. So when we take a look at our numerator and simplify that, we can FOIL it. First times first is just going to give us x plus h. Last times last is going to give us a negative x on the numerator, and then the outer and the inner are going to cancel, aren't they? Because we got the same term here. This is a negative and a positive. So it looks like a minus b, a plus b type thing. So we end up with a numerator that looks like that, and a denominator. And let's see what we have in our denominator. We have h times this thing. So that's h times the first term, which is root x plus h. And then the second term, root x. And so we can say in the numerator, then we have h, and we have an x and a negative x. So those are going to go away, aren't they? So in the numerator, we have h, excuse me, then we're just going to have h in the numerator. And in the denominator, we'll have h and root x plus h and plus root x. And those h's will cancel. So we'll end up with 1 over root x plus h plus root x. And that should be what we have left. Okay. Questions?
So why did you multiply by the conjugate?
That's what we do to get rid of radicals, right? If that radical were in the denominator, we would have multiplied by the conjugate. Now it's in the numerator, so we do the same process. If we have 1 over a radical, we multiply by the radical, and if it's an a plus b in their radicals, we multiply by root a minus b, and that gets rid of the radicals. That's the object, is to see if we can get rid of those radicals. And when we did that and reduced it down and simplified, our solution ended up with 1 over root x plus h over root x.
So we multiply by conjugates even if the radicals in the numerator?
Yes, that's true.
Okay. And also, how did you get x plus h minus x? Did you do a minus b?
Where are we? Which line are we looking at?
the one where you did the FOIL, multiply the conjugate.
This one here. Okay,
Yes.
we had root x plus h minus root x, and here's the conjugate. Okay, and so multiply first times first, we get x plus h, right? That's this. Root x plus h times root x plus h is just x plus h, isn't it?
Yes.
And root x times root x is just x.
Yeah.
And outer and inner are going to cancel because it's a conjugate. And this is a negative. So it's this term minus this term. And the x's cancel, so we're just left with h over this. H is cancel, so we're left with 1 over root x plus h plus root x.
Okay, thank you.
Yep. Any other questions before we sign off?
Could you do 1.7, sorry, P.7, 123?
Is that an assigned problem? P7 123. Let's see what that looks like here. P7 123 was not an assigned problem. Before I do that, is there anybody else that has any problems that were assigned? I'm having trouble hearing you.
Sorry, P.8, number 49.
P8 49. Let's take a look here. P8 49. Let's see here. We can bring that up. First, I have to find it. P. P8 49. Let's see. P8 49 says you ride your bike to campus distance of 5 miles. So this is one of these problems where we're looking at distance equals rate times time, isn't it? Ride your bike a distance of 5 miles. So that's going to be 5. And going to campus mostly downhill, 9 miles an hour faster. So sometimes we can build a matrix. Sometimes it works. If we do that, let's just see distance equals rate times time. So if we're 9 miles an hour faster than your return trip, the round trip takes longer than 7. What is the average velocity of the return trip? So we're going 5. Distance equals rate times time. So if we solve, let's see, we're trying to solve for time. So if I say t equals d over the rate, if I say T equals D over the rate, because that's what we're trying to solve for, then let me rewrite this as, in one direction, it's 5, here's distance over rate. So when it's 9 miles an hour faster going down here, so going to campus, the rate is 9 miles an hour faster. We don't know what your rate is, but whatever it is, it's plus 9 miles an hour faster. That's time going to campus. And then if we say round trip time from campus, we said that was 5x. So this is from. So this is time going, time coming equals, and it says if the round trip takes 1 hour and 10 minutes, an hour and 10 minutes is 60 plus 10, or 70 minutes, or 70 over 60 is the number of hours it would take. And is one hours and minutes. What is the average velocity in a return trip? And these are given in miles per hour. So this is miles per hour here. So we want this in miles per hour. So if one direction is 70 minutes, hour and 10 minutes, and the other is that, so that's 7/6 hours. Let's keep everything in hours because it's giving you, this is rate in miles per hour. This is miles per hour. And so the total time in miles per hour is 7/6 miles per hour. So that's the equation that we have to solve right here. And we got that by looking at distance equals rate times time. And we're solving for this. We put it in the formula of distance over rate is time because we're given everything in terms of time. So this is a time, this is a time, and this is a time. So now forget the word problem and just say, are we able to solve this equation? And if so, then what will we do to solve it? And we need a common denominator, don't we? So this is an x plus 9, that's an x. So this needs an x and an x. And then we've got a 6 here. So we need a 6 and a 6. So now we've got 6x and x plus 9. And this is an x, so we need an x plus 9 in the numerator and denominator. And we need a 6. And over here, we need an x and an x plus 9 and an x and an x plus 9. So now we have all common denominator, 6x times x plus 9. If we multiply through by that common denominator, those will cancel. And so now we've got 6 times 5 is 30x plus 30 times x plus 9 equals 7x times x plus 9. So it looks like 30x. So it looks like we can simply simplify this and then solve for x. We have one equation and one unknown. 30x plus 30x plus 270 equals 7x times this is 7x squared plus 63x. And then we want to simplify, don't we? So we have a 7x squared. And then how many x's? We have 63. And then we've got 60 here. So it looks like we're going to have just 3x when we subtract this. And then we've got, bring this to the other side, we'll have negative 270 equals 0. So let's stop right there and make sure that we agree this is what we're trying to solve. There's no use solving it if we have an error at this point. Okay, so 7x squared, 63 minus 60 is 3, and 270 didn't change. Okay, so if that's the case, we just need to factor this thing. Okay, so let's see, if we want to factor this, I guess we could say 7 and 1 is an option. 7x and x would give us that. And then we need some factors of 270 that will give us a 3. So the real issue here is going to be how we factor this thing. And we'd have to list the factors of 270. And it turns out that, let me do a multiply here, get my calculator out. Yeah, it looks like that 45 and 6, there's lots of different factors, but 45 and 6 does work. So if I put 45 and 6 here, first times first is 7x squared, last times last, 6 times that is 270. And this says the signs are opposite and the larger is positive. 7 times 6 is 42. So the larger is here, smaller is there. 7x plus 45 is 0. X minus 6 is 0. X equals 6. And here x equals negative 45 over 7. And this would give us a negative velocity, wouldn't it? This gives us a positive velocity, and we're looking for miles per hour. This is a negative miles per hour, so we're going to reject that one and say that our solution is the speed we're looking for. The average velocity on the return trip is 6 miles per hour. Miles per hour. Okay. Questions on what we did there?
I'm confused on how why you multiplied 7 over 6 by x.
That's the number of, everything is in miles per hour. So they said it took 70 minutes, 60 plus 10, 70 minutes. 70 minutes is how many hours is 70 minutes? And
I mean, where on the bottom where you're doing, when you're solving the algebra, 5x plus.
down here?
No, just above where you're setting the two equations equal to each other, and then you're trying to solve for x. Right here.
Right here?
Yeah. Just above that.
Here?
Yeah.
I wanted to make sure that I had a common denominator so that I can get rid of the denominator and just use the numerator. So on that problem, we started off with 5 over x plus 9. So if I give you that as a separate problem, 5 over x plus 9 plus 5 over x equals 7 over 6. These are all times, aren't they? So if I ask you to simplify that and combine these values, these are fractions and I want you to combine them. Can you do that?
I would have the common denominator of 6x times x plus 9.
That's right. That's what we had.
Okay, so we also multiply the 7, 6 by the common denominator, I believe.
Well, we need a common denominator. That means we need a common denominator for all three of these fractions. So this has a 6, this has an x, and this has an x plus 9. So this needs an x and an x plus 9, doesn't it? Needs this and it needs this. And whatever we do to the denominator, we do to the numerator. So it's x and x plus 9. This has an x, but it needs a 6 and an x plus 9. So we put a 6 here and an x plus 9. This has an x plus 9, but it doesn't have a 6 and an x, so we need a 6x. So the denominators go away, and we're left with just the numerators that we can now solve for.
Thank you.
Sure. Other questions?
I don't need to talk all the time, but for P.4, for number 61,
P461. Let's see what P461 looks like. P461, and what do we have to do? Find the product. Let's see here. P461, it's x minus 3, y, and 2x plus 7. And it just wants you to multiply those. Is that what we want to do? Is that the one we want to do? Just want to FOIL that? Is that what we want to do?
and I don't think it's plus 7, it's plus 7y.
You don't want 61, you want 71?
No, I meant, the second is a binomial. It's 2x plus 7y.
Oh, 71. Did I read that wrong?
No, 7y.
Oh, 7y.
Yeah. Mhm.
Let's see. Problem number 60. Yes. All right. So again, this binomial times this binomial. Is that what you want to do?
Yes, please.
And can you use FOIL to do that?
Yes.
So first times first gives me what?
The 2x squared.
And outer gives me
So 7 7yx or
7xy. And then inner gives me
negative 6xy.
negative 6xy. And last gives me,
Negative 21y squared.
okay, so far so good?
Yes.
Okay, so 2x squared and then 7xy minus 6xy. Is that just xy
Mhm.
minus 21y squared? Is that what we get when we multiply them?
Yeah. Do you have to simplify further, or is that it?
Well, are we able to simplify that any further? If we simplify this, we're going to end up going back to here, aren't we? I mean, you could say, well, no, let's factor that. Well, if you factor it, you're going to go back to where you came from, aren't you?
Sorry. I
So-
noted that this was a question I had difficult time on when I was doing the homework, but I guess it wasn't as difficult as I was thinking. Sorry.
Okay, no problem. So we're just going to FOIL that, aren't we?
Mhm.
Okay. All right. Good.
I have another question.
Yeah.
For 1.10,
1.10,
yes, number 41.
110, 41. See if I can find that. 110, 41. Okay, is that the one that has x squared plus y squared equals 16?
It's a word problem, I think. 1 It talks about two vertical poles on the table.
Am I looking at the wrong one? So you want 110, 41. Well, let's see here. Maybe I'm looking at the wrong problem here. Where's 110? Here's 110. Number 41. Is that talking about a 6-foot pole?
Yes. 2 poles.
Let's see here. Let's see how it reads here. 110, 41. 2 vertical poles. Okay, 2 vertical poles. 8 feet and 6 feet. And okay, so if that's 6 and this is 8, and okay, so let's just do it that way. And they're 10 feet apart. So this distance and this distance is 10 feet. Okay. And cable reaches from the top of one to some point on the ground. So some point on the ground, we don't know where it is. So we've got point on top of the pole here, okay. Between the poles, and express the amount of cable used as a function of the distance from the 6-foot pole to where the cable touches the ground. So from the 6-foot pole, that would be from here to here. So we're going to call that some unknown distance because it says express the amount as a function distance from the 6-foot pole. Okay. So if that's X and this is 10, then what's this distance here?
10 minus X.
10 minus X. Okay. And the function, then let's see, express the amount of cable. So the amount of cable is going to be, maybe I should color it here. So the amount of cable, I guess, is going to be this plus this. Is that the amount of cable? Here and here? Does that look right?
Mhm.
Okay. So if that's the case, we need to find this distance and we need to find this distance, which happen to be the hypotenuse of a right triangle. So the hypotenuse, this distance here, do we know what that is? Do we have enough information to say what that's going to be? What is this distance right here? I'll call it D1. I'll call this D2. So D1 equals what?
Isn't it X squared plus 36?
So the distance is going to be the square root of this square plus this square, isn't it? Pythagorean theorem. So
Yes.
we could say D1 equals the square root of X squared plus 6 squared, which is 36. How about this value over here? If I call this D2, that's going to be the square root of what? 10 minus X square plus 8 square. That look right? So if we say as a function of X, it's going to be this plus this. It's going to be D1 plus D2, D1 plus D2. D1 is going to be the root of X squared plus 36 plus D2, which is going to be this thing. So 10 minus X quantity square. So that's going to be 100 or positive X squared and what, negative 20X, and then plus the 64. So it looks like that's going to be the root of this stuff here, which looks like it's going to be X squared minus 20X plus the 10 squared plus 64. So that's going to be plus 164, isn't it? Okay, so we've got f of x equals d1 plus d2. Here's d1, here's d2. We just had to simplify this to get d2. So it looks like that the function is root x squared plus 36 plus x squared minus 20x plus 164, and we just leave it in that form. Make sense?
Could you please, for D2, could you explain how you simplified it? Maybe I just can't read it.
D2, this is 10 minus x, and this is 8, and that's D2. So D2 equals the square root of this length squared, which is 8 squared, plus this length squared, which is 10 minus x squared. 10 minus x squared equals 10 times, we're going to FOIL it. 10 times 10 is 100. Outer and inner, so we've got negative 10x, so that's negative 20x, and plus x squared. Okay. All right, and then what else do we have here? Plus the 8 squared is 64. That's this value here. So this is this, this is this. So D2 is 100 plus 64 plus this plus this. So putting them in order, x squared minus 20x plus 164. That's D2, which is this value here.
Thank you.
Sure. Okay. Who else has a question before we sign off?
Could we do P.823?
P823 is not, again, not an assigned problem. 21 and 25 are the assigned problem. Anybody else have an assigned problem before we start doing unassigned problems?
I don't mean to take
Can you speak in your mic? I can't hear you very well.
Sorry, I have 2 more problems that I'd like to go over if that's okay. 1.10, number 13.
Okay, and what's the other one?
The other one is 7.2, number 25.
25, so 13 and 25 doesn't, oh yeah, 25, that is an assigned problem, okay. 110, 13, 110, 13, what does that look like? 10, 13. Let's see. The annual yield per lemon tree is fairly constant at 320 pounds. Okay, when the number of trees per square acre is 50 or fewer. Okay. For each additional tree over 50, the annual yield per tree for all trees on the acre decreases by 4 pounds due to the overcrowding. Okay, express the yield per tree, Y, in pounds as a function of the number of lemons per acre, and that's given as X. Okay, so let's see. So rereading that, annual yield, and we want the annual yield, annual yield, express the annual yield. Okay, so here's the annual yield, Y. And the annual yield as a function of the number of lemons per tree or per acre, number of lemon trees per acre. So we don't know how many lemon trees per acre there are. So I'm going to say function of X. We don't know how many trees per acre. Okay, equals. And what does that equal? Is constant at 320. Okay. If the number of trees per acre is 50 or fewer. But if it goes above 50, then we're going to have to start reducing. So this is a question of, well, we're going to have to start reducing. It's going to be less than 320 for every tree over 50. So this is one of those situations where you say, well, if we have 51 trees minus 50, so now we're one tree over the 50. And we reduce it by how much? Well, we reduce it by 4 pounds. So we reduce it by 4. So 320 is what we get. But if we have 51, we reduce it by how many? Well, 51 minus 50 is 1, so reduce it by 4. If it's 52, we reduce it by 8 and so forth. But this value here has to be above 50, doesn't it? We don't know what it is, but it has to be above 50. So I'll say I don't know what it is, but for every value above 50, whatever that value is, I have to reduce it by 4. If this value is less than 50, then I don't even need this. So if it's greater than 50, I'll put in a 4. So I'm going to say then the yield is going to be 320 minus 4 times whatever that X value is. So then I simplify. That's 320 minus 4X plus the 200. Just distribute this negative 4. So 320 plus 200, that's 520 minus 4X. So the yield Y then is going to be 520 minus 4X. It'll look like this. Okay, for the first part of that question. Express the yield in pounds as a function of the number of lemon trees per acre. Okay, and then we're assuming then that this is lemon trees per acre above 50. So it'll look like that. Okay.
So I had a question. So this won't work if the trees is less than 50, right?
Well, you have to read the problem. You have to read the problem for each additional tree over 50.
So, but won't we have to specify that if X is greater than 50, then this will be the equation then?
That's the equation for each additional tree over 50. The problem reads for each additional tree over 50. This is each additional tree over 50. If we don't have additional trees over 50, then this isn't the right formula. If we're over 50, then X is going to be greater than 50.
Okay, thank you.
Other questions?
Are we allowed to do more like recent problems?
I'm sorry, do what?
Are we allowed to do like more recent problems as well?
Oh yeah, we haven't finished this one yet. We've still got to do these, but yeah,
Okay.
we'll just come back once we finish these guys here. All right, so that was the first part. Express the total yield for an acre in pounds as a function of number of lemon trees per acre. Express the yield as a function of number of lemon trees per acre X. Yield. So one is yield per tree. This is yield per tree. The total yield then is going to be the number that we just solved for, which is this thing here. This is per tree. This is per tree, but we want the total yield per acre. So we're going to multiply by the number of acres. So we'll just multiply by X. So that'd be 520 minus 4X times X. So we get 520X minus 4X squared. So it looks like then the total is going to be this value here. We just multiply by X, 520X, and then minus 4x squared. So that would be the part B for problem 13. For problem 7.2, let me take a look at what 7.2 looks like. Section 7. Where is 7? Section 5. Seven two number 25. 14, 19. How does that read? 7, 2, 25. Let me read how they're phrasing that. Seven, 2, 25. Solve each system. And so 25. Oh, okay. So this, we've got x plus 2 over 6 minus y plus 4 over 3 plus z over 2 equals 0. And take a look at this. This is going to be a long solution. So let me get your name and we'll go through that. We won't necessarily take everybody through that unless they want to wait, but we'll wait till the end. Who is it that had this problem?
Ruthie.
Ruthie, okay. We'll do this at the end, Ruthie, because it's got 3 equations and they all look like this. So solving this is going to take a while to get through. All right, so I'm going to save that one. Who is it that had that one? Was it you, Omar? Did you have one? Or was it Gopal?
Yeah, I also had one. I think it was P.823.
P.823. Well, we're jumping all over today. P8. P823. See what that looks like here. P823. The other one says things did not go quite as planned. You invested 8,000 in a stock that paid 12%. Is that the one?
Yes.
Okay. So we invested 8,000. That's at 12%. Rest of money suffered a loss. So we had a total amount of money we have in the rest. So we don't know what the amount is at 5% loss. So that was a negative 5%. If the total annual income from both was 620, that's the interest, isn't it? How much was invested at each rate? Okay. So we have some amount invested at 12%. And we have some other amount invested at 5%. So let's think about this. If we don't know what the amount is invested at 12%, let's see, let's read that again. What is it saying here? You have 8,000 total that you want to invest. That's this. And part of it's still 12%. So let's see, if we say the amount invested, let's just say X amount invested at 12%, 0.12. We don't know how much, but 12%. So we invest some amount at 12%. We don't know what it is. And then we also then have the rest of it. So if this unknown amount is invested at 12%, how much is invested at 5%? It's going to be this minus the X, isn't it? So that's going to be 8,000 minus X. We have total investment here. So whatever was invested at 12% was not invested at the 5%. Okay. So our equation then is 0.12X. And then this was a loss. And so instead of getting a gain, we're going to have a loss. So I'm going to put a negative here because this was a loss. And the return, it said, was total return was 620. Okay, so we've taken the word problem and created an equation. 0.12x minus 0.05, and minus because it was a loss. 0.05 times the amount invested, which is 8,000 minus x equals 620. Okay, so on a problem like this, to me, the most difficult part is just setting it up. Now, once you've got this, are you able to solve this?
Yes.
Are you able to solve this? We just do the multiply, don't we?
Yeah.
So 0.05 times 8,000 is 400. So that's minus 400. Negative times a negative is a positive 0.05 x equals 620. So we combine our x's, and that's 0.12 and 0.05. So add those together and we get 0.17x equals 620. And then we're going to bring the 400 over. So that's 6, that's what, 1020. So x equals 1020 over 0.17. And let's see, 1020 divided by 0.17. Looks like that's, what is that? 1020 divided by 0.17. Looks like that's 6,000. Okay, so it says 6,000 is the value we get for x, and that's x was the amount at 12%. So 6,000 at 12%, and the remainder, well, that's 6,000 from 8,000, so that's 2,000 at 5%, which generated the loss. So how much was invested in each one? 6,000 at 12% and 2,000 at 5%. Okay, make sense?
Yes, thank you.
All right, who else has a question here? Let's see. Ruthie, will do yours at the end. It's going to take a while to get through that. Anybody else have a question before we move on to the last problem?
Could you do 8.2, number 17?
8 to 17. Let's see if I can. Where is 8 to? Let's see. I can locate it here. Let's see if I've got the right one. Is that x plus 2y? Let's see. 2. Let's make sure I've got the right one I'm looking at here. E217. That's x plus 2y plus 3z equals 5. And y minus 5z equals 0. And we are asked to eliminate and solve. All right. So if we say solve this for y, for instance, we could say that's y equals 5z. And if I plug that back into the first equation, I get x plus 2 times 5z plus 3 times z equals 5. So that says x plus 10z plus 3z equals 5, x plus 13z equals 5, or x equals negative 13z plus 5. Okay, so I've got x is there and y is here. So I've solved for x and y. And when we solve for x and y in terms of z, we've done problems like this before. When the only thing remaining is z, then we can write this in two ways. We could say our solution set would be x, which is negative 13, z plus 5. Y is 5z, and then whatever z is. Okay, we could write it that way, or we could say, z represents time, and these values here depend on time. But either way, they depend on z. So we could either set it up as z, or sometimes the book will talk about, z really is time, and these locations here are moving as a result of time. But our solution, we could write it just like this: negative 13 z plus 5, 5z, and z. That any of those, that would work. Questions of what we did there?
Basically, since the book said negative 13t, that's basically negative 13z as well.
Yep.
Okay.
Plus 5, right?
Yeah, of course. Yeah.
Yeah. Okay. Yeah, the book is just saying if you put in a t there for z, that just says let z equal t. And let me see if go back here and look at some of these answers here that they've specified. They'll specify it. Let me just see if they've got an example here. I don't see where they've converted that, but yeah, if your solution is based on on Z, and you can either leave it as Z or you can put it as T, whatever you prefer. It's whatever this value is. Use
So
go
I
ahead.
had a question. So
Yep.
the book says to use the Gaussian elimination, which the book says is the matrix. So could you show how we would solve that using the matrix?
If we want to use a matrix, we would put in our equations, and we're given, let's see, what are we given? Just two equations. Yeah, we're just given x plus 2y plus 3, z is 5, and y minus 5z is 0. So if we put that into an augmented matrix, x, y, z, 1, 2, 3, 5, 0, 1, negative 5, 0. You notice what we have here? Okay. So if we have 1, 2, 3, and 5, 0, 1, negative 5, and 0. So our augmented matrix is going to look like that, isn't it? So this says negative 5z equals 0. And if you solve that, you get z equals 0. If you solve this, you get 2y equals, you get 2y plus, well, I guess I should put in the x here as well. X plus 2y plus 3z, and z is 0 equals 5. So that goes to 0. So x plus 2y equals 5. So if you use an augmented matrix and go through what they want you to do is x, y, and z, well, we've only given two equations. So if you're going to do that, let me see, what would they ask you to do here? So 17, 8, 2, 17. Seventeen says, yeah. So when we're doing Gaussian elimination, that's what we just did, wasn't it? Let's see. Let me find an example of that number. Yeah, so see if they've got an example here. Yeah, it looks like to me that what they're saying is because we have y minus z is 0, when we set this up, there isn't a unique solution because we don't have the value that we could solve for z here. We've got in terms of z, we can set it up. We can say y minus 5z is 0. I guess I shouldn't put that there because z could be whatever. So when we set this up, what does this say? When we're looking at this Gaussian this augmented matrix, and we see that we've got our diagonal of ones followed by zeros underneath it, and then say what equations are generated. The equation is 1y minus 5z. That equation is generated. and x plus 2y plus 3z. So we've get y minus 5z is 0, and we get x plus 2y plus 3z equals 5. We get those two equations, and we can solve them in terms of z, but we can't go any further than that. That is to say, our solution set would be y equals 5z. We could put it that way. And we could say, substituting that into the x equation, we could say x plus 2 times 5z plus 3z equals 5, x plus 10z plus 6z equals 5, and that says x plus 16z equals 5. So we could solve it in terms of z. X equals negative 16z plus 5. So that's like we've done before. We've got x in terms of z and y in terms of z, negative 16z plus 5, and y is 5z. And z, you could leave it as z as far as I'm concerned, or label it t if you wanted to. But when you go through and solve it, you end up with these values that you get from this equation by putting it into the augmented matrix.
So for z, wouldn't we put in the exact value, which would be y over 5?
No, no. Z, we don't have an exact value for z.
I mean,
Because
by exact value, I mean it would be y over 5 if we set y minus 5z equal to 0, and then we put
yeah, you could do that if you wanted to. Sure, yeah, you can do that.
okay.
Yeah, as we've shown here, y equals, yeah, that's fine. Yeah, I mean, if you want to show that, that's fine. But just work these, just go through whatever. If you had to do some row operations to get the diagonals and the zeros, you would do that too. But just show your work. Just be sure you show your work whenever you're going through these problems. That's mainly what they're going to be looking for.
Okay.
Okay, other questions before we exit for the day?
Could we do P.7 123?
Which one?
P7 123.
P7 123. Let's take a look. That was not an assigned problem. 121 was assigned. Let's see, what is it asking you to do here? For each radical equation, check all proposed solutions. So what do we have here? 2x plus 19 minus 8 equals x. All right, what method could we use to solve that?
Could we add 8 to the x and then square both sides?
We could. So if you've got 2x plus 19 equals x plus 8, square each side, and you get x, 2x plus 19 equals x plus 8 squared is going to be what? Go ahead and work that out.
I think it will be x squared plus 16x plus 64.
Squared plus 16x plus 64. Okay, so now we have to simplify, combine, get everything on one side. What'd you get when you combine both sides?
Is that x squared plus 14x plus 45?
14x plus 45, and that equals what?
0.
0. Good. All right. Anybody disagree with that? Have we done our arithmetic properly there? Okay, if that looks good, now are we able to solve that? That is to say, are we able to factor? That's going to be x and x. And we want to combine the factors of 45 to get 14. 9 and 5 is 45, and 9 and 5 is 14, isn't it? So we can say 9 and 5, and looks like everything is positive. X equals -9, and x equals -5. Now, if x is -9, and we plug it into the original equation, 2 times -9 is -18. Does that work?
No.
Okay. So that solution works, doesn't it? So the solution set ends up to be -5. X is -5, this value here. Okay.
Okay, thank you.
Yeah. Okay, everybody. So the plan then on the 15th, make sure you log on, I would say by 2:45 to 2:50. That way we'll make sure that everybody's logged on and we get your test to you. You can download it and you have 3 to 4:50 to work on it.
I'm going to go over the questions.
Yeah, Ruthie, we're going to do yours as soon as everybody's done here. And let's see, give me, do I have it down here? That was, what was the problem number again, Ruthie?
7.2, number 25.
7255,
25.
7225. Okay. All right, we'll do one more and then we'll be done for the day. 7225. Let's see what that looks like here. All right, let's take a look here. I think I've got the right problem up here. 7225, that's x plus 2 over 6, right?
Yes.
Over 6 minus y plus 4 over 3 plus z over 2 equals 0. Let's double check that. 72, make sure I'm doing this. Searching for what they want here. 72. 25. Yeah, x, solve the system's x. So that's the first equation. Second equation is x plus 1 over 2. Y plus, no, y minus over 2 and minus z. over 4 equals 9 over 2. And equation 3, x minus 5 over 4 plus y plus 1 over 3 plus z minus 2 over 2 equals 19 over 4. Okay, let's take a look here. 6. So it looks like it's going to be easiest if we can get a common denominator for this guy and then combine the numerators. So looking at equation 1 only, if we combine those into a common denominator, what do you think that common denominator might be? Couldn't hear you.
6.
6, okay. So if we multiply through by 6, let's see, we'll have this multiplied by 2 and 2 and 3 and 3. So 6. So we're going to end up with x plus 2. And then minus 2 times, and what are we going to have there? We're going to have 6, that'd be 2, negative 2 times y plus 4. Y plus 4. And over here, we're going to have 3, 6 times, so it'll be 3 plus 3 z equals 0. So we'll end up with x plus 2 minus this. So let's go ahead and simplify it. X plus 2 minus 2y minus 8 plus 3z equals 0. So x minus 2y plus 3z equals, we have negative 6. So it looks like that's going to be equal to 6. So we have one equation simplified as x minus 2y plus 3z equals 6. Okay on that one?
Yes.
Okay. And let's see if we take a look at, let's see, is there anything else we want to do with that? How about the second equation? Should we take a look at the second equation in the same manner?
Yes. The denominator, the common denominator would be 4.
All right. So multiply this by 2, this by 2. That's, so we'd have 2x plus 1 plus 2y minus 2 minus z equals 18. Check my numbers as we go through this. 2x plus 2y minus z equals 18. Here we have 1, negative 1 plus 1, so it's going to be 19. So 2x plus 2y minus z equals 19. Is that what you got?
Yes.
2x plus 2y minus z equals, oh, looks like that's, is that, I don't think we did this right. What did we do wrong here?
I think instead of
This is 18, isn't it? This is, we've got an error here. Let's see. This should be 2x. Well, no, let's see.
is it
2x
2x plus 2?
2x plus 2.
Because
Plus 2 and minus 2. Those cancel, don't they? Yeah, that was plus 2 minus 2. That was a plus 2 and this is a minus 2. So those are going to cancel. Yeah. So 2x plus 2y minus z equals 18. Yes. Yeah, it's a plus 2. That's plus 2 and a minus 2. So here's our second equation. And then our third equation. So our common denominator here is going to be, what do you think? It's going to be a multiple of 4, isn't it? So 8 is a multiple of 4, but 3 won't go into it. So it must be 12, huh?
Yes.
So we'll do 3 and 3 and 4 and 4 and 6 and 6 and 3 and 3 here. So it looks like it's going to be 3x minus 15 plus 4y plus 4 plus 6z minus 12. And what's 3 times 19? 38 plus 19. Looks like that's 53. Is that right? 19 times 3. That doesn't look right to me. 57. Didn't read that right. So let's simplify and see if we agree here. So we get 3x plus 4y plus 6z, negative 15, negative 12. That's negative 27. 4, negative 23, positive 23. Carry 1, 7 equals 80. Is that going to be right? 3x, 4y, 6z, 80. If we've done our arithmetic properly, it looks like that. Agreed? Those are the 3 equations?
Yes.
Okay. So now we can use whatever method we want to solve these, can't we? We can graph it. We can substitution. We can do elimination. We can do about anything we want. Anything you suggest. Let me rewrite them here. I'm going to say x minus 2y plus 3z is 6. There's a first equation. Second equation, 2x plus 2y minus z equals 18. And 3x plus 4y plus 6z equals 80. All right. Let's see if anything pops out. Well, it looks like we have a plus 2 and a minus 2 situation here. So if we combine these first two, we'll get 3x, and the y's will go away, and 2z equals 24. All right. And now we want to see what we can do to the second 2 here. What can we get rid of here? We want to get rid of a y. So it looks like if we multiply this times a negative 2, that would give us a negative 4. So negative 2 here be negative 4. So it looks like that's going to give us a negative x. Negative 2 here. That y is going to go away. We'll have negative 4 plus 4. Negative 2 here be positive. So it looks like that's going to give us an 8, doesn't it? Plus 8z equals, and what do we have here? Negative 2, 36. I'll have to get out our calculator here. 80 minus, what, 36? Looks like that's 44. So after doing that set of reductions, we end up with 3x plus 2z equals 24, and negative 8, or negative x plus 8z is 44. So now we down to here. And can we then get rid of something here? Well, it looks like if we multiply this times 3 and add it to the first one, we'd be okay, wouldn't we? So 3x plus 2z equals 24. We'll multiply this equation by 3. That gives us a negative 3x, positive 24z, and 3 times 44. Looks like that's 132. And if we combine this, we get what? 26z equals 132 plus 24. Is that 156? And that goes in what, 6 times? So did we get a z equals 6? We agree with that? Is that what you get? Okay, so if z equals 6, we can plug that back in up here, can't we? Solve for x. And when we solve for x, what are we going to get? And you plug in 6 for z, what do you get? Negative x plus 48. Z equals 44. Bring this over, negative 48. So negative x equals negative 48, or x equals 4. So now we got x and z. Again, doing a back substitution to solve for y. So we can plug in x and z. And solving for y, what did you get when you plugged in x and z? In that first equation, 4 minus 2y. What'd you get?
Plus 18. Oh, sorry.
Y equals, were you able to solve for y?
No, I'm sorry. I'm still going to.
Okay.
Okay, never mind. Sorry.
X is 4 minus 2y plus 3 times z. Z is 6, that's 18, equals 6. Negative 2y equals 18 and 4, that's 22. Over here is negative 22. 6 from 22, that must be 16. So y equals, negative y equals, so y is going to be equal to 8, isn't it? That's going to be negative, so it's going to be y equals 8. So it looks like our solution set is 4 and 8 and 6 for our solutions here. Okay, so we just reduced them as we've done in the past. Just, I guess the most difficult part might have been to get a common denominator for each of the three, but once you get the common denominator, then we just go through and we can solve by elimination. And when we did that, we got 4 for x, y is 8, z is 6. Okay.
Thank you.
Thank you, everybody. So we'll see you. When am I going to see you next then? Let's make sure we all agree.
Wednesday.
Wednesday, the 15th at what time? 2:50. Very good. Okay, everybody. Have yourself a good weekend. We'll see you on the 15th.
Thank you.
Thank you, Professor.